Hello guys, welcome to Big Book. Today we are going to discuss on reducing sugars, reacting with Benedict's, FEHLING's and Tolen's reagent, and also acidic KMnO4 and K2Cr2O7, potassium manganese oxide and potassium chromic oxide. So first of all we have to understand the reducing sugars. First of all, we have to understand the reducing sugars. These are the simple sugars which include monosaccharides and most disaccharides. Some examples of reducing monosaccharides are glucose, fructose and galactose. And a few reducing sugars disaccharides are lactose and maltose. Remember, here is a note where the disaccharide is the sucrose, which is not a reducing sugar. It will not react with any of the reagents to get reduced and give the precipitate. Now here, why it is that the reagents or the solutions are going to react with these reducing sugars, and how we are getting the reaction. Here the sugars are having the aldehyde functional group or the ketonic functional group. As per the first point, the aldehyde functional group is the reducing agent in reducing sugars. Reducing sugars have either an aldehyde functional group or have a ketone group in an open chain form, which can be converted into an aldehyde. So here readily these aldehydic functional group or ketonic functional group are going to react with the whatever the reagents, that is, it can be the Tolen's reagents, FEHLING's solution, Benedict's solution, or acidic KMnO4 or K2Cr2O7. They are going to readily react where they are going to oxidize those reagents or the solutions or acidic solutions to give rise to the new component, that is the carboxylic acids or the ketonic, that is the carboxylic acids from the aldehyde and the ketone. So here that is the second point. Reducing sugars have an aldehyde or ketone functional group which can reduce the soluble ions present in the Tolen's. That is, the soluble ions will be present in the reagents, that is like Tolen's solutions like FEHLING solutions and also the Benedict's solution, and also the acidic KMnO4 and K2Cr2O7. Next point is a reducing agent donates electron during a redox reaction and is itself oxidize. So here reducing agent is the one, that is the, let it be a Tolen's reagent or the solution, that is the FEHLING solution or the Benedict's solution or the acidic KMnO4 or K2Cr2O7 is the reducing agent. So here these are going to react with the aldehyde functional group, where this aldehyde or the ketonic functional group is going to react with these particular reagents and solutions or acidic solutions to give the precipitate. The qualitative test produces a color change from the blue, green, yellow to orange to the brick red. This point is on the basis of the Benedict's test, where the qualitative test will be observed from the blue, green, yellow, orange to the brick red, depending upon the amount of the reducing sugar is present in the sample. Coming to the next slide, this slide shows the very clear picture of the reaction of the reagents or the solution with the either with the aldehyde or the ketone. So in this slide the table has been tabulated, where reagents has been kept in the first, aldehyde is the next, and the ketone is the third group. So here in the first group, Tolen's reagent, which is the ammonical silver nitrate solution, which is going to react with the aldehyde but not with the ketone, because ketones are the strongest bonds compared to the aldehydes. So here these ketones will be having the double bonded nature, so there the reaction will not take place where the Tolen's reagent, that is the ammonical silver nitrate solution, will not react with the ketone, but with the aldehydic group of the simple sugars it is going to react and reduce to the carboxylic acid, and a precipitate can be observed. Next is FEHLING solution. In this copper sulfate plus sodium potassium tartrate solution will be present, where this is going to readily react with the aldehydic functional group of the sugars, simple sugars. So further, it is also not going to react with the ketone. Next is the Benedict's solution, where the copper sulfate and sodium citrate solution is the mixture of this Benedict's solution, where this copper sulfate sodium citrate solution is going to react with the aldehydic functional group, giving rise to the carboxylic acid and the precipitate, and it is also not going to react with the ketone. So further is the acidic KMnO4 and K2Cr2O7. These are readily react with both aldehydic functional groups and also the ketonic functional groups of the sugars. So here, particularly when you are going to consider KMnO4 and K2Cr2O7, these react to give carboxylic acid readily without any heat treatment. But for the ketone reaction, or to get a precipitate or the result, we have to give a water bath, hot water bath, or the heating of that particular sample. So here, this is what the added point to this, but we are going to get the result. But in TOLLEN'S, FEHLING's and BENEDICT'S, even on the hot water bath also, we are not going to get any result. Either you boil it on the flame directly, the sample in the test tube, or you boil it in the water bath, you are not going to get any results. So next is reagents chemical reaction, that is the Tolen's reagent test, how it is going to react with the reducing that is the aldehydic functional group. So here you can see RCHO, it is the formula of the aldehyde. R stands for the any of the compound, can be easily oxidized to RCOOH, that is the carboxylic acid. But here one thing you have to understand, the formaldehyde is not going to reduce with the Tolen's reagent. So because the formaldehyde is readily going to react with the ammonical silver nitrate to give rise to the carbon dioxide, but not to the carboxylic acid. So here it is not going to give rise to the RCOH, that is the HCOOH is not going to form. Instead of that, it is going to reduce to the CO2. So here in the formula you can observe that this RCHO is going to react with the ammonical silver nitrate, and it is going to give rise to the RCOOH and the 2Ag and 4NH3 plus 2H2O. So here this is going to reduce, oxidize, it is going to reduce with the this one, that is the silver test, like the precipitate is going to be formed, that is the silver is going to precipitate. Here this precipitate is going to appear as the silver, which we are going to smear on the back of the mirrors, where we have mirrors at our homes, where we see our faces or the reflection. In those mirrors will be having the silver, which has been coated at the back of it. That silver is going to appear in this reaction when this ammonical silver nitrate of Tolen's reagent is going to react with the reducing sugars aldehydic functional group. It is going to give rise to that particular precipitate, that is the reduction of the silver by giving rise to the RCOO minus or RCOH of the carboxylic group. This is how a particular reaction is going to takes place with the help of the Tolen's. So here Tolen's reagent is only responsible, or is only going to react with the aldehydic functional group to give rise to the carboxylic group, but it is not going to react with the ketonic group. So it is not so strong to react with the ketonic group. Next, in this slide we are discussing on FEHLING solution test and its chemical reaction. Actually, aldehydes reduce FEHLING solution from Cu plus 2 were reduced to the Cu plus, which is an alkaline solution of cupric acid ion of Cu plus 2, complexed with tartrate ion. So that is the FEHLING solution. FEHLING solution is having one exception of not reacting with the benzaldehyde. So here it is not going to give any reduction of the benzaldehyde as similar to the Tolen's reagents formaldehyde. So here it is having the reaction of RCH4. Here you can observe RCH4 2Cu 2 plus SO4 minus, and here 3OH minus, and it is going to give rise to the RCOA minus plus Cu2O plus 2H2O. So here there will be the red precipitate. In Tolen's we found the silver precipitate. Here it is going to be the red precipitate. Here you can see that the aldehyde functional group is reducing the agent, that is the FEHLING solution chemical, that is the copper sulfate. It is reducing it to give rise to the red precipitate. So here reducing sugars or reducing the reacting reagents or the solutions with them. So here it is reducing and giving rise to the new precipitate by giving rise to the separate carboxylic group, where the precipitate is of the reagent which is formed because of the reaction within the aldehyde group, but the main sugar is going to give rise to the carboxylic acid. So here this is the difference. Now here this is how Tolen's and FEHLING solutions test reaction, and also having the, so here in this slide you can see that the BENEDICT'S test, where it is also similar to the FEHLING solution test. In this you can observe this is the aldehyde group. So here CH4 has been observed, and also you can see after the reaction COOH. Here it is having the sodium citrate with the copper sulfate, and it is going to react to give rise to the from D-glucose to D-gluconic acid. So here you will find the red precipitate, and also this is the chemical reaction where while preparing the reagent there will be the sodium carbonate and sodium hydroxide, and it is going to give rise to the formation of the reagent. So after the formation of the reagent we are going to test this reagent with the glucose to give rise to the D-gluconic acid and Cu2O, where the red precipitate will be observed. So this is how the BENEDICT'S solution is going to react with the reducing sugars. Here also BENEDICT'S solution is specific only to the aldehydic functional group but not to the ketonic group. Now here the last is the acidic KMnO4 and K2Cr2O7 test. Here acidic KMnO4 is going to readily react with the formaldehyde to give rise to the carboxylic acid. You can see, and it is going to react to form the HCOH, and it is the formula. Now here ketones, here you can see even with this KMnO4 and K2Cr2O7 both react with the aldehydic groups and also the ketonic groups. Here you can see the ketone, where you can see the oxygen oxidizing and reducing the agents which is substituted with the functional group or whatever the sample. Here Cr2O7 2 minus plus H plus has been observed, and here you can see the acid, carboxylic acid with the carbon dioxide and the water released. So here this is how the acidic KMnO4 and K2Cr2O7 is going to form. As similar to the Tolen's, FEHLING's and BENEDICT'S solution, this aldehydic group will react to give readily the precipitate respective to the whatever the reagents present in the Tolen's, FEHLING's or BENEDICT'S solution, but for similar. So here, but here ketonic reaction, here the boiling is required, but here for the KMnO4 the boiling is not required. Readily we will get the result, but here the boiling is required because the ketonic bonding is strong, where it has to disrupt to give rise to the precipitate or the result. So this is the chemical reaction of the acidic KMnO4 and K2CO2O7 test. Now here coming, so here followed by this all reagents, we will discuss a little procedure on Benedict's test. Before to the procedure, we will speak about reagents required. Benedict's reagent: dissolve 173 gram of sodium citrate and 100 grams of anhydrous sodium carbonate in 600 ml of hot water. Dilute to 800 ml with water. So this will be the reagent 1. And again dissolve 17.3 grams of copper sulfate 5H2O in 100 ml hot water and cool it. This will be the reagent 2. Add reagent 1 to reagent 2 slowly with constant stirring. So as the reagent 1 is excess in amount, we have to add that particular huge amount of the reagent to the small amount of the other form of the reagent, so that the reaction should happen uniformly. So here we have to stir slowly and we have to add, and further we have to make that 800 plus 100 ml of the reagent, which is already 900 ml, to 1 liter. That is, we have to add 100 ml of the distilled water to it, and we are going to make it to 1 liter. So here a note is that sodium citrate is the chelating agent, which will help in the reaction of the reagent with the solution. Further is the procedure for Benedict's test. Add 2 cm³ of the sample solution to a test tube and add an equal volume of Benedict's solution to the test tube and swirl or vortex the mixture. So here we are going to mix the sample and the reagent or the Benedict's solution properly, vortexing in the sense we are going to make up and down of the test tube or the whatever the sample container which we have taken into. So we are going either we are going to swirl in the sense we are going to rotate by keeping in equipment where the mixture has to mix properly, and later we are going to leave the test tube in a boiling water bath for about 5 minutes or until the color of the mixture does not change. So here this is the optional, depending upon the sample you have taken. This is the optional. Certainly we are going to use water bath to get the result instantly or within the time of the whatever the boiling water bath of 5 minutes. But here certainly if we are going to add the reagents to the reducing sugar, it is going to give the result. Observe the color changes during that time as well as the final color. So here the color changes in the sense as we have discussed, the blue, green, red, yellow and brick red. So here these are the color changes, where as you add immediately you will not get, if the sample is having the high sugar quantity, it is not going to show immediately the red precipitate, but as the amount of the reducing sugar is going to react with the reagent, that amount of the or the quantity of the precipitate is going to precipitate and it is going to show the color. So observe the color changes. To prepare a control, so here it is a control is that the distilled water where the control remains the reagent's color itself. So next point is the qualitative test produces a color change from blue to green to yellow to orange to the brick. Qualitative test in the sense here we are going to only observe either way reducing sugar is present in the sample or not, but we are not going to estimate any amount is present in the sample or not. So here it is only the qualitative test but not the quantitative test. So here this is regarding the procedure. Here this is the picture depicting the result. One is the blue where the none, the next is the trace, next is the lower moderate, next is the high, that is the 4. And as we have discussed that blue, green, yellow to orange to brick red. After the orange, that is the last test tube, it shows little bit orange also the red also. So here if we are going to get more darker color, that is the big red, so here you can see the orange. So this whatever these results we got in the lab, those has been shown in this slide. So here this is regarding the reducing sugars reacting with Tolen's reagent, FEHLING's reagent, BENEDICT'S solution, and acidic KMnO4 and K2CR2O7. So this is how the reducing sugar reduces or get reacted with the other reagents of the solutions or the acidic solutions to give result or show that they are present in the sample. So this is regarding the whole about this particular slides or the video log, and we will come with the new topics on particularly on the phylums, and we will upload very soon so that it helps you guys to go through and make yourself the best out of that. So please spread the word about this big book of the YouTube, and also help us to share this content with your friends and also the other college mates. And please provide the feedback if the slides are good or good, if the slides also bad, if the slides are also bad, please provide the comment. And also please provide if anything has to be updated on the slides, so that we can come with a one more round of the slides within this particular experiment. Thank you guys for watching big book, and help us to make more productive slides so it help you guys to understand better. Thank you for watching big book.